Okay, this is Group 3's parking monitoring system. We utilize two sensors, sensor A, sensor B, parent sensor, child sensor. Both sensors must be in agreement that it is a vehicle before it actually sends it off to the back end with a detected class and a timestamp. From there, the back end will then report the occupancy, entry exit data, and generated forecasts. When the Android app requests for that data, the back end will simply give it that data. So what makes ours different from what we see here? So ours will utilize two sensors for the entry and exit. As we'll see in the real world here, we see that each parking spot has an individual sensor, which costs a lot of money and is not necessarily as efficient. So our system is providing a solution to that, a more efficient solution and cost-effective, but still providing the same result. So we're going to jump into the actual hardware that we're using, and then we'll be jumping into a setup demonstration. You'll see our 3D printed case. Inside, you'll see a Grove Vision AI module connected to an S3 shell board, all powered by a lithium-ion battery. These two are all packed into a 3D printed case that we designed. And now we will go ahead and get into how we actually set up this system.
To set up a new system, initially log into the admin user interface. We can set the name and capacity for any zones, as well as add zones. For new sensors, they will provide their own access point initially that we can connect to. Once connected, we go to the IP address of the sensor and provide the wireless information. We also need to provide the backend URL and save this configuration. And within a minute, it will report to the backend. The backend provides a handful of REST APIs. Some of the APIs are used for the mobile application, where it can get current occupancy, historical, and future occupancy. It also provides this information to the prediction service for training. The admin has a few dedicated REST APIs for management of retention as well as prediction, and then a set of APIs for zone management. The backend is written 100% in Python and uses a MongoDB for information storage. It's deployed using Docker Compose to Amazon AWS and is divided into several containers. The backend provides the primary REST interfaces. The prediction service is also provided using Fast API, and it is trained synchronously with the backend every hour. Also hosts our own MQTT broker as well as a MongoDB. The prediction service uses a random forest regression for predictions it uses the last 30 days to form predictions for the next 12 hours. And that's done asynchronously each hour.
Before we get into a demo, I wanted to show you guys how our sensors are working together. So we'll see our first sensor there is the child, our second one here is the parent, and their 3D cases, and they are simply mounted on these poles, angled in the outward direction, looking for cars coming into the parking garage. As we can see here, a car will enter the parking garage, will pass our two sensors, and then we'll simply increment the back end on the app here. We will see the occupancy actually decrease on our mobile application here. In conclusion, we have successfully demonstrated our system, how to set it up, and showing it successfully working in a parking area. So our goal is to save people time, whether it's college students, hospitals, airports, or festivals. We want to save users time by providing a more efficient way for parking. So our system involves hardware, software, and machine learning components that make it robust and reliable for the users.